Tech Study channel. So in the previous class I have explained types of attributes, okay, which is the part of fifth question's answer, okay. And till now we have completed fifth question and its answer, and in this class I will explain diagram for banking schema. So I will explain sixth important question and its answer. So for I will explain only banking schema, okay. University schema and an employed schema I will explain in the upcoming next class, okay. Uh, so I will explain in this class diagram for banking schema. So here are the topics: diagram, and in that diagram what are the entities and what are attributes, relationship types, and mapping cardinalities. Each mapping cardinalities in relational database with example, okay. So before understanding this diagram, we will look at some points of entity relational database, which is data model. So data model, we already know it's a blueprint for designing the database, okay, in the DBMS. So entity relational data model means it is based on the notion of real world entities and relationships among them. While formulating real world scenarios into the database model, the model creates entity set, relationship set, general attributes and constraints. By using these entities, relationships and general attributes and constraints, we are designing the database, okay. In this particular entity relational model. So entity we already know. I think in the real world that we want to store information about, an attribute having entity having properties called attributes. Domain, every attribute is defined by its set of values called domain. Attributes is also called column, okay. Means domain means a specific varchar domain or int domain, etc. like that. Varchar domain stores only text values and int domain stores only numeric values in a particular column, means in a particular attribute. Every attribute is defined by its set of values called domain. This is used in tables, okay. And then relationship. The logical association among entities is called relationships. Mapping cardinalities define the number of associations between two entities, okay. How the values of one tables are related to values of another table. That's the mapping cardinalities, okay. And how many times they are related, okay. Mapping cardinalities shows how the values are related to each other in both tables. Means how the first table values are related to second table, and how the second table values are related to first table, and how many number of times they are related to each other. So that is called mapping cardinalities. There are one to many and one to one, one to many, one many to one, many to many. 4 types of cardinalities are there. So these mapping cardinalities we have discussed in the data model video. So I'm not explaining this again. Okay, and then naming and conventions. So this is important for implementing a diagram for relational model. So naming convention rules that ensures clarity and consistency when designing a database by which both the technical team and business stakeholders can be read. These are the rules, okay, which ensures the clarity and consistency. Okay, for, for entity using singular nouns like student, not students. Okay, and starting with capital letters. Okay, or entirely uppercase. In the ER model, suppose this is the ER model. This is entity is represented by rectangle, student entity, and it should be start with capital letter, or whole thing we have to write with uppercase. And a singular noun, it should be a singular noun. In student, not students. Okay, and then every entity must be unique name. Means in a diagram we can't have two duplicate entities, repeated entities. Okay, avoid technical jargons, means hard words like so here technical jargon means facilitate, means in simple word we can use help. Okay, and technical jargon like terminate, and simple word stop, and utilize and use. Like this we can replace technical jargons with the simple words. So we are avoiding technical jargons while creating an entity. For attributes using singular nouns, using camel case or start with capital letters. Camel case means a set of words is there, for example. Okay, using camel case, this is the set of words. So here U is a small letter and C are capital letters. So except starting word, remaining words are starting with capital letters. So that is called camel case, and or with starts with capital letter. And entity name is used as a prefix to clarify the attribute, like customer address or employee address. So like we will create a table, entity table, student table. Okay, in that student name, student ID, student marks, like that we are adding prefixes student to every column, means adding to every attribute. And in customer table we add employee name, employee ID, like that, employee salary, like that. And for primary key must be underlined. Okay, if an attribute is a primary key, then it should be underlined in the diagram. And for relationship, use a present tense verb like works for, enrolls for. Okay, not worked for, like that. Okay, enrolled, not used like that. Okay, names readable from left to right or top to bottom, left to right and top to bottom in the diagram. And then, so as we can see here, many to many relationship is there, and many to one relationship is there. We will say that there is a relation between account and branch, that is many to one, not one to many, because it is readable from top to bottom, not bottom to top. Okay, and here we will say many to many and many to one, not one to many. Okay, and then these are the symbols. For entities rectangle, weak entity double rectangle. For all types of entities rectangle only, and weak entity double rectangle relationship rhombus or diamond, identifying relationship double rhombus, and attribute oval, key attribute oval with underline, multi-value attribute double oval, composite attribute uh, like branches of a tree. Okay, and which are connected to ovals, and derived attribute dotted oval, and total participation of E2 in R means double, it is represented by double line, and cardinality ratio 1 to many between two entities, and structural constraint many comma maximum on participation of E in R. So means how many times this entity values are participating in this relationship. Okay, if minimum number of values are participating in this relationship, then we will consider minimum value. If maximum number of values are participating in the relationship, then we will consider maximum value, that value as a maximum value. Okay, this is I have explained in already in the ER relational model video. Okay, if you want detailed information, then you can go through that. Okay, and then here is the diagram, ER diagram for banking schema. Entities. So first entities: customer, account, loan, branch, and payment. These are the entities represented by rectangles, and attributes represented by ovals. These, and relationships represented by rhombus. Okay, borrower, depositor, maintains and offers, has. Okay, these are the relationships, and types of entities in this model. Strong entity, an entity that exists independently of other entities, means it has a primary key. Means customer has a primary key, customer ID, which is underlined, and branch has a primary key, branch name, and loan has a primary key, loan number, and account has a primary key, account number. Then weak entity, an entity that can't be uniquely identified by its own attribute alone and depends on a strong entity. Example payment, which depends on loan. Here it is indicated by double rectangle, weak entity. Okay, which is dependent on loan entity, which is a strong entity because it has a primary key. As per the definition of strong entity, we already know it should have a primary key, that is in this case loan number, which is indicated by underline oval, and then means this payment number is a partial key. Okay, partial key means a key which does not uniquely identifies a row unless it combines with a primary key of the stronger entity, which is loan number. Okay, then if it is combined with a primary key of strong entity, then both can uniquely identifies each rows in the table. Then tangible entity, a physical object, example a customer or physical branch building. Okay, customer is a physical object and branch building also a physical object. That's why it is a tangible entity. And intangible entity, a conventional object that has no physical form, example account or loan or payment. Okay, because a physical real world person, customer is a physical real world person and branch is a physical building or branch location. And intangible entities, a logical agreement or record keeping a balance of funds, that is account. And loan is a financial agreement, contract, debt, obligation. Obligation means is our legal or financial duty to repay the borrowed money. So these are all logical entities which are not physical. Okay, payment a transaction or a transfer of funds to fulfill a financial obligation. Means we can't touch by our hands. Okay, these are only logical, imaginary. Okay, it is there but it is logical. Okay, and then associative entity, a relationship that is treated as an entity to link multiple entities together. Like depositor connects a customer to an account. Here is a depositor which has attribute access date and access type. This relationship is treated as an entity. So that's why it has attributes, means columns. Means because it is treated as entity. Because it is treated as entity, so it has columns. Okay, the relationship has columns. Okay, so associative entity means it holds the relationship, means connects customer and account, means through deposit future, it connects the customer and account, and it has its own attributes like access time and access date. So that's why it is called associative entity. So relationship definition is what? The association between two entities is called relationship. So associative entity means it holds the relationship and also it holds the attributes of its own. Okay, and then types of attributes. Here partial key is a payment number, because it is a weak entity, that's why it is a payment number, is a partial key. And then key attribute, a unique identifier for an entity, example customer ID, account number, loan number, branch name, which is underlined by in the customer entity, the customer ID is underlined, and loan in the loan number, the branch name, and the account entity account number. These are the key attributes, which is also called primary keys, which uniquely identifies each row in that entity or table. And simple attribute, an an atomic value that can't be subdivided. Here example is account balance. So these all types of attributes and entities I have explained in the fifth question and its answers videos. So if you watch that, then this can be easily understandable. So simple attribute, an atomic value that can't be subdivided. Means a table can't hold list of arrays. Okay, data. Here example is account balance. Account balance. Means for a specific account, the balance is only one. Not more than one values are there. Okay. And then composite attributes, an attribute that can be divided into smaller subparts. Example, address, which contains street, city and zip code. State, pin code and house number. I have provided different examples for composite key. So this attribute is divided into smaller simple attributes. Okay, these attributes can't be divided further. Okay, and then multi-valued attribute can hold multiple values for a single entity. Example, customer having multiple phone numbers. Here we have customer entity. In this, phone number is an attribute which is represented by double circle, as we have discussed in the naming conventions of relationship types. It should be double oval for a multi-valued and attribute. Means it has multiple phone numbers. Derived attributes, an attribute whose value is calculated from other attributes. Like example, age derived from date of birth. Here age is derived from date of birth, which is represented by dotted circle, dotted oval. Okay, and then we have mapping cardinalities, means relationships between entities. Okay, so number of associations between two entities in the diagram. Okay, first is many to many. Customer to account. Customer to account, which is related as a depositor. So it is a many to many relationship. Okay, which is represented in the diagram by MN. Okay, customer to account, many to many relationship is there. Okay, one customer means what's the definition of many to many relationship in ER model? That is so each row in the first table can relate to multiple rows in the second table, and each row in the second table can relate to multiple rows in the first table. That's the definition. Okay, so here one customer can hold multiple accounts. Okay, means customer tables. Okay, customer tables, one customer can hold multiple accounts, and one account can be held by multiple customers. So through such as joint account. Okay, and then customer to loan relationship, that is also many to many. Okay, the relationship is as borrower. Okay, customer to loan, many to many, m to n. Okay, so here a customer can take out several loans. Okay, and a single loan can be associated with multiple uh, borrowers. Okay, means customers. A customer can take several loans, and a single loan can be associated with multiple borrowers or customers. Okay, and then one to many. This is in between loan and payment entities. The relationship is as has. Okay, a single loan can have multiple payments. Okay, like if we take a loan, then we have to pay monthly. A fixed amount we have to pay monthly. Okay, that's the payments. Okay, a single loan can have multiple payments associated with it over time. However, each payment belongs to only one loan. Okay, these all payments, monthly payments, are belongs to only one loan. Okay, that's why it forms the one to many relationship. Here single loan is having multiple payments, and each payment it belongs to one loan. So here we are in any type of mapping coordinates, we are stating this stating example, like first we state a statement from one to many, and then we state another statement from many to one. So here a single loan can have multiple payments, that represents a one to many relationship. Okay, and each payment belongs to only one loan. So here each payment means multiple multiple payments belongs to their respective specific loans. Okay, that is many to one relationship. So that's the process of statement making. Okay, in each mapping coordinates. So this bank to account mapping coordinates I will explain. Here many loans are issued by one branch. Okay, many loans are issued by one branch, and one branch can issue many loans. here many to one relationship is there. Many loans are issued by one branch, and one branch can issue many loans. So one to many. Here many to one. We are stating statements like that. And then so one to many definition in the entity relational model is one row in first table belongs relates to multiple rows in the second table, and each row in the second table relate to exactly one row in the first table. Okay, means each row in the first table relates to multiple rows in the second table, and multiple here each row in the first table, we can say one also. Okay, each row in the first table relates to multiple rows in the second table, and each row in the second table can relate to exactly one row in the first table. That's the definition of one to many. And in branch account, branch account relationship type is many to one. Okay, many to one. So many to one definition in the ER model is each row in the first table relates to exactly one row in the second table, and each row in the second table relates to multiple tables in the first table. Means exactly opposite to the one to many definition. Okay, and then that's why we are saying that many loans are issued by one branch, and one branch can issue many loans. Here in the one to many, we are saying that a single loan can have multiple payments associated with it over time. However, each payment belongs to only one loan. Okay, then I have explained these four relationships, four different types of relationships by using a tables, means in a relational database. So first branch to account. Okay, no, it is not here. So first is customer and account entities. So it has a many to many relationship. Okay, customer tables has customer ID, customer name, date of birth, phone number, house number, state, PIN. Here customer ID has a primary key. Customer ID is a primary key in the customer table, and in the account table account number is a primary key, and another attribute is balance. As we can see in the diagram, account has balance and account number attributes, and customer has address, phone number, customer name, customer ID, date of birth, and age. Okay, age I didn't drawn here in the table because it is a derived quantity, means it is only used in query type. in query time we will access the age attribute. Okay, because if we add age, then severe redundancy will be there. Okay, that's why we are not including age column. We have seen in the definition of derived attributes that it is accessed during run query time using some functions. Okay, if I include age here, then here customer name can be repeated twice, thrice and multiple times. So the age should also be repeated for that equal number of times. So it will create a duplicate values. So it will cause severe redundancy. So that's why we are not including it, and at runtime we will access it. And then here many to many relationship is there. So here in the relational database, many to many relationship is not possible. Okay, directly. Okay, directly means we can't insert customer ID primary key of this customer table as origin key of this accountant table, and we can't insert account number primary key of this account table in the customer table as a origin key, because if we insert that, then it will cause redundant values, means duplicate values. Means if I put account number at this place, okay, so then customer name and date of birth, phone number, house number and state pin should be repeated for each account number. Okay, because it's a many to many relationship, means one customer can hold multiple accounts, means here the accounts are repeating, means account numbers are repeating here. For that, these all values should be repeated. Means John Doe has some account number A9001. So in the many to many relationship, a customer is holding multiple accounts. So in the many to many relationship, one customer holds many accounts, means A9001, A9002, like that some more are there. So that person, that customer is John Doe. So for that, the date of birth, phone number and the house number and state pin should also be repeated for these multiple different account numbers. So here in these columns the values are becoming redundant, so the severe redundancy will occur. That's why we avoid this direct mapping of many to many relationship. Okay, and if we place customer ID in this account table, then also it will create a redundant value, like I have explained in this customer table. So customer ID, if I have placed here, then C101, C101 and C101. C101 has two accounts. Means in the many-to-many relationship, one account can be held by multiple customers. This, okay, one account, this one is having multiple customers like C101, C102, C103. These three customers are belongs to only one account number. So for that we have to create three rows, and we have to insert balance 5000 for each row. Means we are duplicating this balance value. Okay, that's why here redundancy will occur. Okay, so that's why we are creating a separate table, which is also called associative table, named as a depositor table, because relationship is a depositor. Okay, one extra point is here, that is associative entity have its own attributes, that is access date and access type. Means along with this relationship, it holds its own attributes. Okay, so here this associative table will bring primary key of first table and primary key of second table and store in its own table, and the relationship will be established. Okay, here how we will see now. Then first, a single customer can own multiple bank accounts. Means C101, she or he appears twice because it is linked to both account A9001 as primary and account A9003 as joint. This particular C101 is linked to A9001 and A9003 as primary access type and as a joint access type. Means here one to many relation, one means each row is related to multiple columns, means multiple accounts, and a single bank account can belongs to more than one person, like a shared or joint family account. Looking at account A9003, it is linked to C101 and C103 as primary and joint access type. Here account what is the account here? A9003. A9003 is linked to C101 and here linked to C103 means a single account is belongs to more than one person. Okay, customer IDs, which are customer IDs here as a primary and joint access, okay, respectively. And then the combination of customer ID and account number together forms the composite primary key. In the depositor table, customer ID and account number for region, both are for region keys. Okay, this combination is called composite primary key. This prevents the exact same customer from being added to exact same account twice. How means? By using the partial key definition and partial key property. So partial key definition is a key which can't identify each rows in the table, all rows in the table uniquely, but if it is combined with a primary key of a stronger entity table, then both together they will uniquely identify each rows in the table. And the property is each partial key value should have unique primary key value. Okay, so here student ID, if we consider student ID as a partial key, then its primary key is account number. Okay, and if we consider account number as a partial key, then its primary key is customer ID. Okay, and both they are combining and representing or uniquely identifying the each row in the table. Okay, so its properties are, the property is partial key. If we consider account number as a partial key, then each partial key value should be unique, should have unique primary key value, that is customer ID value. So A9001 has a C101, that is unique. A9003 have unique customer ID, that is C101, and A9002 also have unique customer ID, and A9003 also have a unique customer ID, C103. That means here we can observe A9003 is here we have A9003 belongs to C101 and C103 customer IDs, which are absolutely unique values, unique customer IDs. So the partial key properties is satisfied. So through which this prevents the exact same customer from being added to the exact same account twice. Means how it will happen? If the property is violated, then it will happen. Means A9003 linked to C101, and also here A9003 also linked to C101. Okay, then two rows are with the same values. So the same customer added to same account twice. So that's why it is preventing it. This property is preventing this exact same customer from being added to the exact same account twice. Here that house number, state and PIN are address attributes. As we can see, address attribute has a PIN number, state and house number. So which are represented as separate attributes in the customer table. Means composite attributes are represented separately in a main table, means in a customer table. Okay, so this many to many relationship is established by using this separate table. Okay, then we have many to many relationship between loan and customer. Loan and customer, many to many relationship is there. Customer and from loan, customer to loan, we have a many to many relationship. So it is similar to depositor relationship. Means the previous example we have the previous many to many relationship we have discussed just now. So similar to depositor relationship, but in this the relationship is not treated as entity. Means it is not a associative entity. Means which means the separate table does not have extra columns. So here a single customer can take, here is the loan table is there. Loan number, amount L101, L102, 25,000 and 10,000. So a single customer can take multiple loans. Looking at C102. Here is the output table, that is borrower table. Here C102 appeared twice. Okay, linked to both loans, L101 and L102. Okay, means a single customer can take multiple loans. Okay, that is we have derived a statement for many to many relationship from at a side. Okay, from one side, from left side. Okay, and then one loan can be borrowed jointly by multiple customers. Means looking at L101, it is borrowed jointly by two customers, C101 and C102. Here L101 and L102 are borrowed jointly. These loans are borrowed jointly. This one loan is borrowed jointly from two different customers, that is C101 and C102. So that's why a loan is jointly borrowed by multiple customers. So here we have derived the statement for many to many means from left side we are considering that is many to many relationship. Okay, so here we have established the many to many relationship between loan and customer by using a separate table. Okay, this is the separate table. Okay, uh, in this loan number is a primary key. Okay, primary key, and in the loan table and in the customer table we have seen customer ID is a primary key. So we are using those two primary keys of respective tables in the separate table, means in the borrower table, as four region keys. Okay, four region keys which contain duplicate values also. In the definition of four region key we have the it can contain duplicate values. So by combining those two primary keys as four region keys, we are establishing the many to many relationship between those two loan and customer tables. Okay, here you can observe a difference between first example, first customer and account relationship, and this loan and customer relationship. That is, the separate the output table does not contain here any extra attributes. Okay, because we are only considering relationship. Okay, here in this first we are considering associative table, means associative entity, depositor as a associative entity which contains its own attributes. That's the specification of an associative entity, which is a separate table, which is acting as a separate table for these two tables and establishing the relationship. And then we have a one to many relationship from account to branch. From account to branch we have a here we have many to one relationship. Okay, because we can see at top we have n symbol and at bottom we have one symbol, so that means many to one. We are reading from top to bottom. So the relationship from account to branch is many to one, or we can say the relationship between account and branch is many to one. So here branch table is contains branch name and location, downtown, west side, New York and California. Okay, so here these locations we have used in the customer tables also, here in the states New York and California. So how it established many to one means, we already know the definition of many to one relationship. Okay, each row in the first table relates to exactly one row in the second table, and each row in the second table relates to multiple rows in the first table. So many accounts belongs to one branch. Here many accounts A9001 A9001 and A9002. These two accounts belongs to one branch down, that is downtown. Branch name is downtown. These multiple account numbers are belongs to only one branch name. That's why here many accounts are belongs to one branch. Means many to one relationship statement we have stated here. And then one branch can contain that particular number of accounts, means many accounts. Here example is one branch downtown contains A9001 A9002 multiple accounts. So here one branch downtown contains A9001 and A9002 accounts, okay, multiple accounts. So we are derived a statement from left side to right side, that is one to many, means one branch name has multiple account numbers, means one branch name contains multiple account numbers, okay. Means branch name means an office. Branch name means an office which can contain multiple accounts and through which there will be multiple account numbers, okay. So how to implement this relationship, okay. So many to one. So the primary key of the one side table, that is branch, must be placed as a foreign key inside the many side table, that is account. So it is the important rule which we have to remember while drawing the output tables, okay. To place where to place the primary key as a foreign key, selecting from both tables. So example, we have branch table and account table is there now here. So in which table we have to, here account number is a primary key here, okay, and here branch name is a primary key here. So which table's primary key we have to place in other tables as a foreign key, so that we can establish a relationship. Means either we have to insert primary key of branch table in the account table as a foreign key, like this, or here is the account table, or we have to insert this primary key of the account table as a foreign key in the branch table. So how can we decide? So by using this important rule. So we can decide where to put the foreign key and from whose table, okay, from which table, okay. And to establish a perfect relationship type, that is many to one. Okay, so the rule is the primary key of the one side table must be placed as a foreign key inside the many side table account. So how to consider a table is a one side or many side? How we want? How would we know that that this particular branch table is a one side table or a many side table, or this account table is a many side table or one side table? Means according to mapping cardinality. Here we have a mapping cardinality many to one. So according to mapping cardinality type many to one, in this case generating a statement like many accounts belongs to one branch. Here the first word is what? Many, and second word is one. So in the statement also we have to write in that same order. So many accounts belongs to one branch. We can't write there is no other way for confusion to generate this statement, because we can't write many branches belongs to one account. Many branches belongs to one account. That is not possible. Okay, that is an incorrect statement. By knowing the meaning itself we can understand it. Okay, many accounts belongs to one branch. So many and one. Okay, by observing underlined words we can decide it. Okay, many accounts means many accounts is the two words in this statement. So it indicates that the account table is of many side. Okay, and the branch table is of one side. Okay, so as we have studied in the important rule, the primary key of one side table, that is branch, must be placed as a foreign key inside the many side table. Means we map this relationship by placing the branch name primary key, okay, of the branch table as foreign key inside the account table, as we have placed here. And we have discussed relationships also. So we are updating account table here. Okay, in the many to many relationship we are using separate tables. Okay, we are using separate output tables to establish relationship, but by updating account table we establish the many to many many to one relationship. Okay, branch name primary key is used as a foreign key in this account table, and account table is updated so that the relationship is developed. Through these statements, okay, which I have explained just now. Okay, and then many to one relationship, from loan to branch. In the ER diagram, loan to branch has a many to one relationship. Means we are reading from left to right. Okay, so loan table is there and branch table is there. Many loans are issued by one branch. Okay, it can be possible. Okay, and example is looking at L101 and L102 are issued by downtown branch. Okay, L101 and L102 are issued by downtown branch. Okay, means here many to one relationship statement is established, and then one branch can issue many loans. Okay, it is also possible. Means we are reversing this statement, okay, in a particular order. Okay, downtown can issue L101, L102 loans. Means one downtown branch is issuing multiple loan numbers, means multiple loans. So that's why it is forming one to many relationship. Okay, and we are stating this statement, and then we map this by placing the branch name in loan table as origin key extracted from primary key of a branch table. Branch name we are using as origin key, which is the we are using branch name as a origin key in the loan table. Okay, to establish relationship. Okay, many to one relationship. Okay, this branch name is originated from branch table, which is in this a primary key. Okay, means this primary key is we are placing here. Okay, so that the relationship is established, and because branch table is one side and loan table is many side, deciding by statement 1. So the statement 1 is according to the mapping cardinality, that is many to one, that is many loans are issued by one branch. So loan table is many side and branch table is one side. So primary key is from one side table. The primary key is taken from one side table and placing in many side table, that is loan table, as a origin key. That's the rule. Okay, one to many relationship from loan and payment. Loan and payment, we have one to many relationship. From top to down we are reading here. Payment is a weak entity dependent on loan. Means weak entity means it does not have its own unique key like a primary key in a strong entity. It only contains a partial key. Okay, which is when combined with a primary key of stronger entity, uniquely identifies each row in the table. So one loan can map to multiple payments. Loan table is there and payment table is there. Loan number, payment number and amount is there. Here the partial key is a payment number. Okay, don't consider this. Okay, these two columns are belongs to payment table. Okay, payment number and amount, P1, P2, P1, 5,000, 5,000 and 2,000, and loan table as it is. So how the one-to-many relationship is established means one loan can map to multiple payments. Yes, it is possible. Payment numbers. Okay. So what is payment number? Sequence of installment counter for a specific loan means it identifies which specific installment in the payment life cycle is being recorded, means is currently going on. Okay. Installment is regular partial payment made to clear a large debt over time. Means regularly we are paying some amount, okay, to fulfill a resultant money. Okay. So L101 made mapped to P1 and P2 payment numbers. Here L101 are stored in repeatedly in two rows. So it is mapped to P1 and P2, which is the sequence of installment counter. It is unique number for each installment, okay, each regular installment. It is different, it has different number, okay. Payment number means installment sequence of installments now. So it is for every day installments it is different. So they are P1 and P2, P3 plus on day 3, for day 3 P3, and for day 4 P4, like that. For day 1 P1, day 2 P2, like that. For every day the payment number changes, but the amount is same, okay. We have to pay fixed amount. So yeah, in this case loan can be mapped to, one loan is mapped to multiple payment numbers, okay. Means one row is, means one value is mapped to multiple values in the second table. Means one to many relationship is established, and then each payment record points back to exactly one loan, P1 record. Means these P1 and P2 payment numbers are belongs to only one loan number. Means for a particular customer, for the same customer there are different payment numbers. Means for different days, day 1 and day 2. So these payments P1 and P2 points to exactly one loan number. Means multiple values are pointing to a single value in the first table. Multiple values of second tables are pointing to a single value in the first table. So many to one relationship is established here. Many to one. So the primary key of the payment table is composite key consisting of a loan number and payment number. This payment table, this is the output table, okay. Means we are updating second table by inserting a loan number column from loan table. Okay, we got the output table. Means primary key of the loan table, that is loan number, is used as a origin key in the payment table, which is second table. So we got the relationship that is one to many. Here the primary key of the payment table is composite key consisting of loan number and payment ID. Here the output contains composite keys. This it's a partial key. Payment key is it's a partial key. Okay, payment number. Okay, it is combining with a primary key and uniquely identifying each row in the table. So that we can identify that if we have same values or same amount values also, so that we can identify each amount whether it is which it is belonging to which loan number and which payment ID. Okay, and here partial key property is also satisfied, that is each partial key value is assigned to a unique primary key value, that is P1 is belongs to L101, P1 is belongs to L102. If it is P1 belongs to L101 and P1 belongs to L101, then it will cause same loan number linking to same payment number, so it will cause redundant data. So to avoid that, the property is preventing them. Okay, the partial key property is preventing them. So in this way, the second table is becoming output table by adding loan number column as a origin key from loan table, and we have established a one to many relationship between two tables. Okay, means by updating payment table we got the one to many relationship. Okay, so yeah, all relationships have completed. In this particular diagram. So that's all for today's video. If you have any doubt, ask me in the comment section. Hope you understand this video. I will see you in the next class. Thank you. Bye.